All right, everybody, home on a snowy day. Hope everybody's doing well and staying warm. This is just a kind of a quick two-part lecture on some of the BMP techniques that we use in North Carolina and what our best management practices and those sorts of things. But before we get into that, just wanted to point out that there is some final exam information. Okay, so you get into the get into the class and you basically scroll down to this lovely picture right here and you'll see final exam information. Okay, and so we have some documents in there. There's a study guide. All right, you use that to kind of go over the topics. All the slides that we've gone through in class are all fair game. There's also some information on the Coweta tour. All right, so for instance, I've marked in the document, let's pull up here, anything with a yellow line by it, I want you to kind of look over and just be familiar with some of those terms, okay? What's been going on with these particular studies, all right? I'm not going to get crazy with it, but I do want you to be aware of what some of the conclusions of some of these studies were, all right? So let me get back to the class here. And I'm going to bounce out. Down towards the very bottom here, I've just combined the last, excuse me, the Coweta field tour plus our snow day assignment. Okay. Now you don't see the videos in here because I'm recording them right now. So, but they'll be located down here. All right. But what we're going to be going over is this idea of best management practices, and I just wanted to introduce you to this Layman's Guide to Road Construction, and that's not anything I'm going to be quizzing you on. We do get into this in the forestry course next semester, but I wanted to make sure that everybody had access to this. You really should print this out and keep it, or at least keep it on your computer, download it and keep it. Because like I said, download it to look over and keep it. It's an excellent resource, and I can guarantee you, if you're going to be doing anything in natural resources in your career, you're going to be referring to this. All right? I mean, it is just chock full of some really good stuff. I'll pull it open and just breeze through it really quick towards the end of the second part of this presentation. Also, what I'm going to start off with, though, is this document here that I had given you early on in the semester. I told you there are going to be readings out of it. So this Journal of Contemporary Water Research, in the study guide, you'll see where I point to looking at certain readings out of here. I've already got it open. I'm just going to go straight to that document. The last reading that I have you do starts on page 60. It's just this one chapter on guiding principles for management of forested agriculture and urban areas. And it covers a lot of the various topics that we've been looking at over the past couple of weeks. What the first thing it kind of talks about is this idea of a paired watershed study, all right, which is exactly what they were talking about over at the Coweta. And just to kind of to show exactly what they're talking about with this paired watershed study, just for those of you, I talked about it in lecture, and I know we discussed it over at Coweta as well. But basically, they have two different watersheds, very similar in size, and in pretty much the same location. And so they put weirs at the bottom of each of them, right there where the stream comes out the bottom of each, and they monitor for a long period of time how much water is coming out of those. So this is the annual discharge of the water going through for 10 years prior to clear cutting. And this is what they call the calibration period. So watershed A, we're not going to really worry about what these units are right here, but let's just say these are billions of cubic feet per year. Okay, so anyway, on average, this is when watershed A drops off 20. It's right here on the line. Watershed B pretty much drops off about 23. Okay, when watershed 25, watershed A has 25 of those units, watershed B has a little bit over 25. Okay, basically what they have is this: they're able to build this through linear regression. They're able to build this relationship so that whenever watershed A drops off so much water, they know they can predict how much watershed B is going to drop off, all right? And so then they go and they harvest one. In this case, I think it says they harvested watershed B. So they harvest watershed B, and then they compare it again. So watershed A during a rainstorm, or during the following year, it has this much water coming out of it. Watershed B may actually be way up here now. So they know what watershed B should have been, but it should be right here. But watershed B is now way up here. So they're able to say, oh, we get this much more water on watershed B than what we predicted would come off of it. And that's how they build these charts. Okay, so during the calibration period, they're pretty similar, right? There's not much difference between, this is the differences between watershed A and watershed B from the prediction, okay? So pretty close, right? But then all of a sudden they harvest watershed B, and then they see this much more water coming off it. So that's how the period watershed study allows them to see, oh, when we do this to it, what are the differences, okay? And there's a whole lot of different period watershed studies that have taken place. Here's Coweta. All right, this is one of the ones that we were just looking at, I believe. And when we were over there, that she was describing those for us. And but there's a number of different U.S. Forest Service watersheds that they do a lot of these studies on. So I just wanted to get you up to speed with that a little bit. This is looking at, when you plant trees, as the trees start to mature, it starts sucking up water from the watershed. So its yield lowers. Okay. So before you had the trees there, you basically had this much water yield. And then after you planted, the trees were sucking up the water. That's kind of what these period watersheds studies look at. And this is, again, this is another one right at Coweta. Okay. So they did a conversion of hardwoods to eastern white pine. And this was their study that led them to say that when you plant white pines on an area, if you convert from hardwoods to white pines, you basically end up with less water making its way down to the stream channel. So if you're trying to harvest water, let's say you're in a watershed for your municipality, planting white pines is probably not the best thing in the world. So, but then the other thing I wanted to point out here, it gets into some erosion, and we've talked about erosion a little bit. Talked about erosion being a two-step process. First, erosion first detaches the particle, and then it moves the particle down further downstream further, or into a stream, and then it drops it off as sedimentation. So erosion, really, the two parts of erosion is the particle gets detached by the energy of the water, and then it grabs the particle and moves it, it transports it. Okay, so you have erosion, which is these two parts, and then sedimentation, where the water loses energy and the particle drops out, and that's where you get sedimentation from. So again, that's a kind of an interesting little part right there. And then it talks about management influences on water quality. And I didn't really talk about this that much, but a meandering stream has much more opportunity to slow down the water and drop the particles off. If you take that stream and straighten it out, which is what happens in a lot of our wetlands, then that water maintains that energy, and it's able to carry that sediment further down. So that's how we end up, when we're channelizing some of our wetlands. Some of the problems that we get with soil making its way all the way to the estuaries. They're kind of talking about a little bit more on a mountainous, higher elevation sort of thing, but it holds true wherever you are. The straighter that stream, the more erosion is going to be able to take place. Then it moves into some technologies that we use for maintaining and keeping water from eroding on roads, because roads are the number one problem anywhere in forestry and development. If your roads are poorly constructed, then you are going to have some real problems with soil erosion taking place. So there are a number of things, and this is really where I'm trying to go with this discussion. Some of the best management practices we have, they describe things such as broad-based dips, so here's some examples of them. Culverts in the streams and stuff like, for water to make its way under the road, turnouts, and all these sorts of things that are important. Okay, so this chapter is pretty good. There's a road that just blew out completely, poorly made road, as opposed to a well-made road. Okay, and so it's got some good slope to the road. They put these broad-based dips in it so that the water drains off the road. The road tends to try to be, for the most part, outsloped a little bit. So, good forest roads, all right? So that's really what I'm going to get into. And then it gets into the actual BMPs. So, so good one to look over, all right? Okay, so I'm going to go back to the class here. And if you get down towards the bottom, you'll see these two guides right here. Okay. First one is this, is just a link to North Carolina Forest Service's BMP's website. And, it's important to know that best management practices are not, they're not laws that you have to follow. They're guidelines that help you to follow the laws. All right. We have statutes that are written in North Carolina called North Carolina Forest Practices Guideline, or the FPGs. Those are our laws, all right? You break those laws, you get fined, you have some real problems, all right? And it's good if you are going to ever get into any kind of management of lands to familiarize yourself with that, because these are guidelines that are related to water quality. That's the number one problem that we have with forestry, is messing up our water quality. So it's basically, really important to know what practices are not allowed by the state. Okay. And so what the state did is they created these voluntary management practices, what we call BMPs, or best management practices. And these BMPs are really suggestions and guidelines that allow you, if you follow these BMPs very well when you're doing forest management, then you're probably not going to have any problems with breaking the law. Okay? So that's kind of an important thing to remember. So you really do need to familiarize yourself with both the laws. It's a big document, it's 100 pages or more, full of, thou shalts and thou shalt nots. And the BMP's book is, these are things that you do to, in the forested environment to, make sure that your logging operation and your management is not going to destroy the water. We're going to concentrate, the second part of this on these, just some of these, ways that we keep water from the roads, because it's the roads, and especially where the roads cross streams or where roads are near streams, that's where most of the problems occur, when we end up with major violations of the BMP, of the Forest Practice Guidelines, FPGs. It's usually violations that take place around these areas here. So, with that, I'm going to sign off on this one, and we'll take a look at this on part 2.